Hello, in this video I'm going to be showing an object detection model that was built from scratch. In simple terms, a neural network is a set of neurons connected to each other, and each neuron has a specific set of parameters, such as the input weights corresponding to each input channel and the bias corresponding to each neuron. Essentially, each neuron will process a set of inputs and will give a specific output according to its activation function. The most common activation functions found within neural networks are rectified linear unit functions. Essentially, the data flows from left to right, going through each layer of neurons. Once it goes to the output neurons, it will throw a prediction probability, and we can compare that with its actual and see how wrong that prediction is or how close to being true is. So one parameter to determine that is the loss. The loss is used to tune the uh, parameters in all the neurons to come up with a more accurate prediction. And this process gets repeated each time in each epoch until we find the optimal parameters. For this project, I'm using a convolutional neural network. Essentially, it's a neural network that has a convolutional layer where it will convolve a matrix that could represent a set of pixels with a filter, and that filter scrolls through all pixels. Um, and basically, convolution is good for predicted patterns, and that's very useful for object detection. For this project, I'm using a convolutional neural network that I built from scratch. Essentially, I'm using an optical microscope that has a camera on it, so I'm able to play on my computer. I am using Yeast for this demonstration. I first began training the model, and this is somewhat a slow process, but it has to run all uh, for accuracy. And basically, the model is almost done. Then once the training is done, I'm able to plot the loss. So this trained model will be considered a good fit. In my program for prediction, once I have imported the model, can count the cells that are present or that are being detected by the model. This could be very useful for applications in biomedical engineering